Welcome back to Fat Mama Physics. This is the second video going over an example on the force due to gravity. I will do one example and you will have another example to try yourself, and the solutions will be played on Fast Play. Here we have a crate of apples having a mass of 34 kilograms. It will be pushed across the ground with this force over here. If the crate only accelerated for 1.76 meters per second, calculate, and we are going to assume this is in the forward direction. We need to find the force due to gravity acting on the crate. So it doesn't seem like we need a free body diagram yet, so let's just get this problem done first. We know the force due to gravity is the mass times the gravity on Earth, which we know is 9.81 meters per second squared. And we know the mass of the crate. We can just put these values into a problem, giving us 333.54. Oh, hey, look, I forgot to take away the answers here. So this gives us, rounding up to two significant figures because of the mass, that is 313 newtons. I even have the right sig figs there. So that is the first problem. Simple. The second question, how much friction force was there to resist the motion of the crate across the floor? So we want the friction force across the floor. This is a tricky, it's a tricky question. I wonder why. Don't forget, only forces along the same axes affect one another. So let's really go over this to see what this means. So we definitely need a free body diagram now. So let's start with a crate of apples being dragged across the floor. So the acceleration, let's say, is in this direction, in which is positive. Let's say that's the positive direction, okay? The crate of apples, starting with a dot in the middle, will have some weight, Fg, which we know already. Because it's on the floor, the floor must exert some sort of force against the box so it doesn't fall through it, which we will just label as the normal force now. We talk about this one later. And assuming this box is not accelerating in the upwards direction, we're going to say that these two lengths are pretty much equal, okay? Now, we also have a force pushing this box forward, and it's something what we call the apply force. Apply force is anything like a push or pull on an object, and this one we have 98.1 newtons. According to this question, we also have a friction force that is resisting the motion, so against the motion, which is forward, in the opposite direction. And since it hasn't caused the crate to either stop or move at a constant velocity with zero acceleration, we are going to assume this is going to be smaller than the apply force, so hence the arrow is smaller. So this is what we are trying to find. We don't know too much about friction force yet, but imagine it's just a resistive force. Now we have a free body diagram. We can go ahead with writing our Fnet equations. We know Fnet is equal to ma, mass times acceleration, and we know the Fnet is in the forward direction because that's where it's accelerating. In fact, we do have the mass of the crate. We know the accelerations given in the question, so we can actually go ahead and to calculate Fnet right now. 5984. And no rounding now because we're not done. So now we have the Fnet. Let's write out the Fnet equation. Well, we know that the force applied is going to help accelerate it. We know that if the object is heavier, it must also make it slower as well, right? And of course, there is the force of friction opposing the box. What do you think? If you think that I did something wrong here, you are right! I totally did something wrong! And this is the tricky part of this question. Many of people will think that if something weighs more, is going to cause the object to not be able to accelerate as much. And that is it's a misconception, which is why I brought this question up. The reason why something is harder to accelerate is not because of its weight, because of its mass. The more massive it is, it takes more to accelerate it. And that has something to do with inertia. It has nothing to do with the object's weight. When we're just dealing with the Fnet, we're dealing with the Fnet along a single axis, as mentioned in this question. Only forces on the same axis affect one another, and Fg is not along this axis. Not even a component of it is along that axis. It's perpendicular. So please, there is no Fg here. I see this I see students making this mistake a lot. Okay, so there is no Fg. So this is what we actually have. Fnet equals to equals to applied force minus the friction force. So if we want to solve for the friction force, we need to isolate it, and let's do that right now. Substituting our values in, we get 38.26, which the two negatives cancel out on both sides of the equation, rounding to 38 newtons in the backwards direction because we're talking about the friction force. And it is as is right there. I just put a negative sign instead of backwards. Backwards is more clear as a communication factor there. So very important, be careful. On the technical side, forces along the same axis, only those affect one another. Otherwise, leave them out of your Fnet equation. Here we have example 4. This is one for you to try, so maybe let's read the question carefully so we understand everything first. The same crate of apples from the previous question, with their mass of 34 kilograms, was lifted upwards this time, okay? But with an acceleration, same acceleration, but this time upwards. Calculate how much lift force is needed to achieve this acceleration, not his acceleration. Okay, so keep in mind this is the upwards direction. This is a good time to pause to try this question, and I will see you back. Okay, here's my turn to do the question. First off, we draw a free body diagram of our apples, and it's accelerating upwards direction. We have the lift force larger than our Fg along the vertical axes, and writing our Fnet equation, substituting in our values for acceleration and mass, we get something similar to above. Our actual Fnet, the sum of our forces, is Fl minus Fg, and isolating for the lift force, we get the following, and the gravity values, force due to gravity is the same as above. We substitute that one in as well, giving us a total of 390 newtons in the upwards direction for lift force. So here we go. This is our solution. So here the lift force I labeled as FL, which can be anything, it really doesn't matter. As long as it's a separate symbol than FG. We've used a lot of answers we calculated from the previous question, but most importantly, when we did the Fnet equation, it was along the vertical axis. So this was Fnet in the vertical or in the Y axis. There were no other forces involved. And notice we have a lift force that is larger than our weight because the lift force not only has to carry the weight, but also has to make it accelerate upwards, which is going to be a lot harder to do. Okay, that concludes this video. Good job on these questions. Good luck on the rest of your practices. Thank you for watching this video, and Fat Mama Physics signing out.